Section 8.3. In this section, first we try to solve some radical problems. Like problem number 1. So here, anytime you want to solve the radical problems, first you have to raise both sides to power of 2. For instance, let's say here I have radical x is equal to 7. To solve these equations, you need to raise both sides to power of 2. When you take radical x and raise it to power of 2, it means you take radical x and multiply by radical x, and that would be radical x times x, or radical x to power of 2, and finally is x. It means anytime you take the radical and raise it to power of 2, doing that, radical is removed. So let's say here I have radical x minus 1 is equal to 3. When you raise the radical to power of 2, doing that, what you have under the radical is released from the radical. For these reasons, you don't have to show all this, but you need to understand. Anytime you take a radical, raise it to power of 2, for this reason, radical is removed, and you have just x minus 1 on this side and 9 on the other side. Then you could just go ahead and solve that. Okay? Now, to do that, you want to make sure that you don't have anything under the radical, next to the radical. Like if you have something like this, and you want to raise both sides, the best thing is to get rid of these numbers first. So you could isolate the radical by itself. Means first you divide both sides by 5 and make it easy. And now radical is alone with no number next to it. So when you raise it to power of 2, then x is removed, or what you have under the radical is removed, and you have 4. Okay? So here in these problems, that's what we did. We raised both sides to power of 2. This one, radical is removed. So 2 plus 7x is coming out of the radical. See? And on this side, what is 2x times 2x? 2x times 2x is 4x2. Now, since this is a second degree equations, and if I want to use the formula, I need to bring everything to one side. Normally, we bring it to the side that has x2 already. See? By putting -2 here, -7x. Now I use the quadratic formula, because if you want to use quadratic formula, you want to make sure that all the terms are on one side equal to 0. So a is 4, b is -7, c is -4. You put all those here and you solve it for x. Same thing here. Both sides, you raise both sides to power of 2. Now, what is x plus 2 to power of 2? Remember, this one means this. You either use the formula, or you just write it as x plus 2 times x plus 2, which is x2 plus 2x plus 2x plus 4, or x2 plus 4x plus 4. Remember? So x plus 2 to power of 2, do not just write x2 plus 4. It always has a middle term. Always has a middle term. Remember that. Okay. So then, this is what you have. Radical is removed here. Bring everything to one side, so that equals 0. We normally bring it to the side that we already have x2. So we bring this 9x to that side. And then you use the quadratic formula. this problem is a fraction. So what you do here is, if you want to take common denominator, here you have x times x plus 2 is your common denominator, then 3 times that plus 4 times that. Then we cross multiply. Remember cross multiplications, that if you have A over B equals C over D, if you have two fractions equal to each other, cross multiplication is this. Numerator of the first one times denominator of the second one is this. Or BC is AD. Okay, that's what we did here. Look, 2 times that and 1 times that, which is 3x and 4x is 7x. See? And then you distribute 2, bring everything to one side, and then use the quadratic. All right. Now, you know, when we give you equations like this and ask you to solve, one method is method of factoring that we practiced a while ago in the earlier chapter. You need to find two numbers whose multiplication is -3, and when you subtract it's +2. So what you do is you put this x on each parenthesis, right? You just refresh your memory for this kind of factoring method. X and x, and then you find two numbers when you multiply is -3, and when you subtract is +2. Since you want to solve it, we take each parenthesis, set it equal to 0. And we find the x. Now, what if you have, instead of x2 and x, what if you have x4 and x2? It's very similar. So what you do here is you need to understand the basic. That means when this is 2 and this is 1, basically you double the power, right? You go from 1 to 2. And here you go from 2 to 4. You double the power. In that case, what I do is I put this x on each side. So here you put x2 in each parenthesis. Sorry, in each parenthesis. Rest is the same. Two numbers is multiple 3. And look at this one. Power is 3. When you double is 6. So what you put in each parenthesis? This one. Look at the similarity here. You put this x on each because you double. Here you put the middle term x2 on each, and here you put x3 on each. Okay. Then we take each parenthesis equal to 0, right? So we take this parenthesis, set it equal to 0. We took this parenthesis, set it equal to 0. Now this one, x2 is -3. Remember, if you take a number and raise it to power of 2, it cannot be negative, so there's no real numbers. But when I take a square root of both sides, you could remove the negative out and put an I. So this one has plus or minus radical 3i, and this one is plus or minus 1. How many answers? 1, 2, 3, 4. Why? Because the highest power is 4. This one, very similar. Remember, when you are taking to solve these problems, when you take the cubic root of both sides, you don't have plus or minus anymore. Okay, let's say you have a problem like this. x3 is 8. And I want to show you the difference between this one and this one. Look. When it's even number, when you take a square root of both sides, you put a plus or minus on this side. Because there is always two possibilities when this is even. Look at this one. You take cubic root of both sides. X is coming out. Here, you don't have plus or minus. It's just one answer. When the power is odd, you don't have a plus or minus. Why not? Because is -2 the answer? Also no, because when you put -2 here, see what happened. When you put -2 for 3, what is -2 to power of 3? Is not 8, is -8. Okay? So in case of odd number, you always have just here, you don't have plus or minus anymore. Plus or minus just in case of even. See, because here, +2 and -2 both are the answers. Why? Because if you take a negative and raise it to the even number, it always give you positive. But that's not the case for 3. 3 has just one answer, it's x equal 2. So remember that just for even power, you always put plus minus, not for odd numbers. See, for this one, look, just one answer. One answer. Okay. All right. So now we are using this property for these problems. Look, this one, we had this formula that difference of two perfect square is a minus b times a plus b. The same thing, because 16 is what? 16 is 2 to power of 4. So you put P2 and P2 on each. See, in this formula, when you have A2, what do you put in each parenthesis? A, half of this, right? Here, what do you put in each parenthesis? Half of this 4, which is 2. And then -4 and +4. And then when you take each parenthesis and set it equal to 0, okay, when you take a square root, remember you always have a plus or minus because the power is even. Here, you end up having a negative number under the radical, okay? You don't have real number, but you do have a complex. So if I remove this negative out, I gotta put an I here. So see, 2 imaginary answer here and 2 real number here. Z2, when you double 2 is 4. So what you do is on each parenthesis, you put Z2. You put the middle term on each parenthesis. Then you need to find two numbers whose multiplication is +36, and when you add algebraically, it's -13. It's -4 and -9. You take each and set it equal to 0. Look. It's plus or minus because it's 2. So plus or minus 3, plus or minus 2. How many answers? 2 and 2 is 4. Highest power is 4. That means the total possible answer is 4. You cannot go beyond 4. But it could be 1 answer, 2 answers, maximum is 4 answers. And here we have 4 answers. Now, this is very similar. It's like, think of this. Think of let's say this is 8. Think of A2 plus 2A minus 3 equal to 0. Let's assume that 5n minus 1 is A. How would you solve these problems? It's very similar, right? You put an A on each. And then you find two numbers whose multiplication is -3, and it's like that, right? A is what you have next to 2. So in this case, what is A? Is this 5n plus 1? So you gotta put 5n plus 1 in each parentheses. See that? And then that 3 and -1, that 3 and -1. And then that 3 and -1, you put it on this. So the middle term in this case is A, it's 5A. You put that on each parenthesis, which is 5n plus 4, and this is 5n minus 3, and then you come up with two numbers. First, what I do is first I take a common denominator. But what I did was, another way to do it is you just multiply every term by 3t minus 1 to the power of 2. See, I put 1 here, 1 here, 1 there, because I want to get rid of all the denominators. So that would make it, this would one parenthesis cancel, cancel. See, you don't have any more denominator. To solve the equations, we should always have everything in one side and set equal 0. We do that. So this is very similar to this. Look, A2 minus 1A minus 6 equal to 0. How would you solve? How do you factor this? You just put A on each, and you find two numbers whose multiplication is -6, okay? And when you add the subtract is -1, so it will be -3 plus 2. So now instead of A, you have 3t minus 1. You know, see how we always put this middle term and put it on each parenthesis? You need to take 3t minus 1 and put it on each parenthesis. Look. Again, you take this and put it on each parenthesis. Very similar to this. A2, when you double this is 4, right? You put A2 on each parenthesis. Find two numbers whose multiplication is positive 42. I mean, subtract -13 is this 2. You take each equal to 0. Because this is 2, you have to put plus or minus. Plus or minus. Before I work on these problems, I bring everything to one side first, remember? Then, if the power is 1, now it's 2. You take this and you put it on each parenthesis. Find two numbers whose multiplication is positive 30, and when you subtract is -11. So with -5 and -6. Okay, so remember this part is like this. It's like A2 minus 11A plus 30 equal to 0. It's very similar to that. You know how you put A, and then you find those two numbers? Same thing instead of A. See how we put the middle term here? You put P plus 4. Is this similar to those? Yes, why? Because to know whether you use the same format or not, you multiply this by 2 to see if you get that one or not. If I take 1/3 and multiply by 2 or 2/1, what do you get? 2/3. Yes, so this is very similar to those. See, the rule is if whatever the power of this is, when you multiply by 2, you should get this in order to use this method. All right. So when I have 1/3 and 2/3, then I can use this method. What if I have something like this? X to the power of 4/3 minus x to the power of 1/3. No, you can't use it. Why? Because if I multiply this by 2, it doesn't give me 2/3. So it has to follow this format that this power is double of this. So in that case, what would we do? If you have A2 minus A minus 12, how would you solve these problems? Don't you put A on each, which is the middle term, and then you find two numbers with multiplication is -4, so it's -4 plus 3, right? Same thing. You put this 1/3 on each parenthesis, look. And then you put this -4 and 3 here. And then you take each parenthesis, set it equal to 0. Now, how do I solve this one? When the power is 1/3, you raise both sides to power of 3. See? And you remember this formula, if you have x to power of m, and if you raise that to power of m, is x and m. You use it here. We raise both sides to power of 3. Means we put a 3 here and 3/1 here. When you multiply this, it just gives you x. And 4 to power of 3, 64. The same thing here, look. See, for this one, again, you're dealing with the odd numbers, so we don't have to worry about plus, minus, stuff like that. So when I raise this to power of 3, 1/3 and 3/1 is just the x, and it's -27. So in order to do this, you always have to have whatever the power is, you got to multiply this by 2 to get the other ones. Look, 1/3, when you multiply by 2 again. But this one is a little bit complicated because this is kind of problem that, remember how we solve this, you have to make it the group factoring and stuff. But you could also use the quadratic. It's easier to use the quadratic. So A, what is A? A is the middle term, right? So instead of this, I put A. And you understand this is the double, so this is A2. So you solve the problem first to find your A. A is what? A is -4/13, 2. What was the A? A was x to power of 1/3. So now, x to power of 1/3 is -4/3, and x to power of 1/3 is 2. Then, in order to get rid of this, you have to raise both sides to power of 3. See, the last few problems get more complicated, but it's just the same rule. Again, the rule is if whatever the power is, when you multiply by that by 2, you should get this one in order to do all this. Get this one. Since I need to isolate radical on one side, I try to always have a radical by itself on one side. So what I do is I bring this -5x here to make it positive and take 10 to that side. And then raise both sides to power of 2. What it does, again, this one, when you take the radical of raising to the power of 2, it just gives you 5x. But what you have on the other side, look, these two. You simplify, you bring everything to one side, then use the quadratic. Oh, long problems. Now, one thing about the radical problem is, although the solution is correct, with the radical problem, you should always check your answers, because what if you come up with an answer that doesn't work? So anytime I'm dealing with the radical problem, when I find the final answers, I plug into the original equations. I put it back here to see if it works or not. One answer was 20, right? So I'll put that here. I put that into this equation. Instead of x, I put 20, right? So I get this. Oh, I get 10. Okay. But when I try 5, I end up to 0. But I need to have 10 on it. I need to have, when you put a number for x, you need to have 10. But here I don't have 10. I come up with 0. So that answer 5 is not a solution. Okay? So there is only one answer to this. So again, with the radical problem, it's always necessary to check your answer, because sometimes the answer it may not work, because when you raise it to the power of 2, sometimes if it's a plus or minus, you may change it to the positive. So you get to check that. And then the very last ones, the last 2. This is the same rule. Remember, you double, you put it on each. Number 14 is kind of word problems, and let's see if I can find the problems here. I want to find a statement of the problem. You already have it. What they have is this. They are saying that, okay, a jogger ran 3 miles, then decreased his speed by 1 mile, and then another 4 miles. So we have this distance formula, okay, that I wrote it here for you. Time is always distance divided by speed. You know, if you drive a car every day, you're dealing with this. When we say, oh, I drove 50 miles per hour, say 50 miles per hour is my speed, right? My speed is 50 miles per hour, means a speed is miles is the distance divided by time, or distance, if you cross multiply, is a speed multiplied by time, or time is distance divided by a speed. See here? So first, he goes 3 miles with the speed of x. We don't know what it is, x. Then he reduces speed 1 mile per hour. So whatever his speed is, he reduces 1. And then he goes another 4 miles. So altogether, from here to here, first we want to calculate the time here. Time is distance divided by speed. Distance is 3 divided by x. What is the time from here to here? Distance, which is 4, divided by speed, which is x minus 1. The total time in this problem is this, is given. Okay, they're saying that here, the total time is 1 and 3/10, which is 13/10. See that? This is if her total jogging time was that. Okay, so this is your equations. Time of the first one plus time of the second one is, then you have to solve these equations. It's all algebra then. First, we take a common denominator here, then cross multiplications. And then you finally come up with 2 answers. One of the answers is 6. The other one is very small. This is not acceptable because you come up with the fractions, which is less than 1, which is not acceptable here. The other one is 6. X is 6. If this is 6, what's the other one? The speed of the second part. You subtract 1. So it's 6 and 5. Okay, so that would be end of section 8.3.